Okay, I think we can start. Good morning, everyone. Um, welcome to my presentation. We tried to and discovered ways how we can enhance OpenEdge development using GitHub Copilot, and we explored it, and we really found something that useful that really helped us a lot. I will be your pilot for today. If something goes wrong, we can blame AI. Yeah, always. A little bit about me. The slide is working. Oop. I need. Oop. Presentation crashed. AI. Yeah. Okay. I'm working with OpenEdge for 10 plus years. I'm driven by challenges. I don't like cats. What scares me? Mega spiders. And what I really like is working in nature. Lately, meditation and continuous improvement. What was our initial goals? So we tried to see, hey, can we use a tool that generate code that help us in OpenEdge, in an OpenEdge project? Can we test the knowledge from one workstation to another? Can we train it using what is already available? Can we accelerate the development? Can we integrate it with other teams? Can we transfer the knowledge? Can we train to a specific framework that most of the projects are using behind a structure? So can we train it based on that structure? We try to figure it out for GitHub Copilot. What are the actually repositories that he's trained to learn from? And can we add our own repository to that one? Of course. Yeah. Let me. It's better. Yeah. Okay. So this was our initial goals. Yeah. Strong. How we did it, I will present you in this presentation. But we did a lot of questioning. So what's going on behind it? What's happening? So we discovered that there is a possibility, and at least one. So that I'm going to present to you today. There are in total four, but let me show you the video. So what we tried, we started with DF. So we have a database, and we tried to generate an OERA simple structure. So we take it from the database structure. We wanted to have completely a service interface, a business entity, a data access, a data set, and a temp table based on what we have in our database. So we export it. So here in this case, we have sports 2000. You can hear the video. Okay. Thank you. And we start prompting. What we see on the left-hand side is the chat version, chat extension for Visual Studio. So we were starting giving him prompts. Hey, generate me a temp table based what I already selected from my DF file, and we start analyzing what was the actually prompt response. So we check it. Okay, something is fishy. We went to another file. Okay, this is the TT department. We check it against it. Okay, this is what we want to generate. The old one was a previous iteration that we tried. And this is the phase when we analyze actually what was generated. So hey, what's inside there is really compilable. Does it make sense? Everything seems to be okay. Now we went to, hey, give me a data set for it. So the prompt is generate a data set definition for department including the temp table definition. Okay, now it's thinking, it's generating, and he returned correctly. So now what we're gonna do, yeah, we just move the code to our DS class, DS include. Opening DS department. Now that we have the DS, we have the temp table, we need to generate the data access. Now we have a previous defined DA customer with fetching, creating, update, delete. We have a DS customer included there. We have a default constructor. Why is there? Yeah, destructor, some methods. Right now we're going back to the prompt and it says, hey, I want a DA department based on existing template, which is DA customer, and to include the data set that we already generated. We want it inside it. So we want the new code based on one that is already existing. Generate me a new one for my DA department class. Now the chat, what's it's doing is showing the prompt after it's refined based on the context. I will talk about the context a little bit later. Give me the new class. First step is to check everything that's generated to make sure it's matching what I'm expecting. Okay. Now it's opening the customer. Yeah, it missed something there. Now we're moving to the business entity. So we already have one template. So from which we can generate. We know that it's okay. So it's already validated BE customer. We want to generate it for the BE department. Just checking, making sure is what we need for the department entity. Make sure, hey, we have a DA here reference, so let's see. Okay, the prompt is based on B customer and include DS department and DA department, generate a B department. Now the chat is generating it. So let's see your. Okay, this version is already defined. Yeah. So we have the structure there. it's enough for start development. To alter it, so we just go to B department and start moving the code there. Yeah. Now we want to generate the service interface. So we just check the one that is already available, SE customer, and we're going back to the prompt and say, hey, generate me an SE department based on SE customer that uses the B department. Also the data set, yeah, DS department included. Okay, it's generating now. It's flushing its buffer. Update department. I see some messages there. Okay. So this is the simple. This is the simple OERA, the simplest OERA structure. Now we have it generated. The code will be moved to SE department class source. Okay, how we reach this stage? We try to look to all possible customization for LLM. There are 4 in total. We can use RAG, in-context learning, supervised learning, or reinforced learning from human feedback. What we see on the right-hand side, fine-tuning part, is based on human interaction directly that validates the response that LLM is returning back. What we see on the left-hand side is using what we first part retrieve augmented, what's already in the context in a vector database, and from there is returning pieces of snippets. And for this example that I've shown you, we used in-context learning. This is part where we train specifically to generate our response, how we wanted the code to look like. And for further, what we did, we took the simplest one from here is in-context learning and tried to have a small number of steps that we can use and replicate on every type of framework. So for this one, we use prompt engineering. This is prompt engineering in base is the steps to train a model based on specific prompts. So all the prompts that we used that should be used have 4 principles behind it. Should be single, well-defined question. You make sure it's really clear, specific, not enough details that model should return, should be short, not too high. This one with the shortness in the latest models is not required anymore, so you can be more generic. And surround enough. You should provide enough information to describe what you want. That including files, context, and relevant information. There are some limitations that we went through. Some of them, yeah, we got a lot of response. Sorry, I can't retain. Sorry, I don't know the answer. Yeah, but what we noticed is that the context should include comments, should include parts of the code, should know the structure, and these help us refine the suggestion. Another limitation, well, another limitation, what we noticed is, based on our goals, we want to transfer what we did on one machine to another. So what we managed to find a workaround is that behind all the prompts or all the training that we did, they are stored locally. But we are locally on the workstation on which we use the IDE, but we can export them. We can export and transfer to other machines. The example that we showed was trained using prompting on my colleague's Alice machine, and he sent me his prompting, and I just started to use it and apply it to on my local workspace. Another limitation that we try to bypass is what are the repositories that are generically by default for the LLM. We cannot add private repositories only on enterprise plan, and here is some, like, you need to buy 10 licenses, 40 euros, 39 euros per license, and then you can add the private repositories, and the model will be trained based on that repository. Another one is a context limitation. We discovered that, yeah, there is a limit, so it's 6,000 characters. After we reach this limit, the response starts to hallucinate really bad, and the number of prompts that we needed to refine the response increased from 2 to 14, 15 prompts only to refine what we wanted to obtain. Another one that we discovered, we need to be specific what we want to obtain, and for this, as a developer, we need to strategically open our sources that we want to be included in the context. In this way, these ones will be first looked and referenced in the context that's sent to the model in order to obtain the response. Another one is security, because the model is not kept local, it's global. Only the prompting is local. The training data for the global model is based on open source repositories, and mostly those, and some of them have security vulnerabilities, and it might be that the code that is generated will have included some security vulnerabilities. So we need to pay attention to these ones. Another limitation, if we didn't strategically open our sources, what we want to reference, Copilot doesn't know. So it doesn't have, as in this example, we try to, hey, can you explain what string utils is doing? Get file name method from string utils. And the response was, hey, I don't have this specific implementation of get file because we didn't strategically open the file, so Copilot can have access to it. Another one sometimes is failing to see obvious optimizations in the code, but this is what we suspected is that the number of code sources that are available for Progress are limited, and the model tries to satisfy our request, even if satisfaction of the request is really bad. So he tries to generate something back. Another limitation, when we try to generate a unit test for a class, as you see here on the right hand side, we said, hey, generate me a class, test class for email BE. We already have an example. You can take the example from stage BE class. Hey, generate me one. He fails to add annotation for everything, but this one can be refined further with next prompts. So hey, in a test you should include annotation. I know here setup, teardown. I think I've deprecated There is before all, after all. Okay. How we did the integration? Currently, Copilot can be integrated with Visual Studio Code. Is working by default, supported. Yeah, but it is specific for private repos. Yeah, that are already available only for Copilot Enterprise package. There were some. We took some metrics based on our prompts and generation of responses. We saw the acceptance rate drops due to multiple prompts that are added. The number of characters reaches faster to 6,000, and from there the number of prompts exceeds, like as you see here, we have number of adjustments on y-axis. On the x-axis we have the number of generated characters. When we reach 5 to 6,000 characters, the number of prompts for adjustment, what we wanted, really increases from 4 to 14. Okay, this is an example. What we see now is an example how we can generate a temp table. So the same that what we see in the video. What we did, we just put there, hey, based on something, generate me something. This is one type of prompt. It's not exclusive to this one. You can use different type of prompts for this. For this one, it worked directly. So we didn't. The number of characters was in the limit. So it generated directly the temp table, the data set. Hey, generate me the data set. This one was directly one prompt. Yeah, for the DA, because now the number of characters increases, we have a little bit logic there. Yeah, the prompts reach to 4 attempts, so 4 refinements. So first one we generated, hey, generate the DA, and we looked at the code, hey, something is missing. So we were refined it, hey, you missed this part, this is important, include it also. So we needed 4 other prompts for it. For a business entity class, also we have 4 other prompts because the code is getting bigger and bigger, the number of characters is increasing, and he start to miss obvious things. What's important here is on the service interface. So we already have a lot of prompts that we did. We have a lot of context characters that needs to be returned. And here for the service interface, it was missing obvious things. So here we need to actually put 14 to 15 prompts just to make sure we have the right code in the source, so we can actually use it and send it to Git. Okay. There are two possible extensions. We used Visual Studio Code for this one, and natively in Visual Studio Code there are 2 parts. So we have the extension for prompting is the Copilot chat, and inline coding is the GitHub Copilot. The difference between them, how are you gonna use it? The chat is conversational. It's used for browser use cases, answering questions, giving you suggestions, understands better the context in which you are. It's more like interactional, so like, hey, give me that, I give you this, I refine that. For the inline, we have suggestions. We can generate directly from the inline code. We have directly autocomplete based on some comments, some triggers actions, and it can provide us directly suggestions if the code is not working. Directly by prompting hints, hey, you need to fix these things because the code will not work. For the Copilot, so we created an account for GitHub Copilot. We tested this one with student or free edition individual and the business business account. The settings that are available, there are 4, only these ones, that make sure the Copilot is available in IDE. Do I need Copilot in GitHub Mobile? No. Copilot in command line, we tried from there, and suggest matching public code, duplicate detection. We said that, hey, allow that. The plans that GitHub provides is Copilot individual. This is for students, Copilot business for organization, and for enterprise level, where the most important thing that we noticed, you can give private repositories and the model will learn from those repositories. Okay. How we set the Visual Studio? So we start to first thing we wanted to configure the Riverside to know the ABL, to know the ABL. So this is the first one that we did. We used OpenEdge 12.7 and we installed a GitHub Copilot and GitHub Copilot chat extension. Pretty much this was the settings to ramp it up. What we noticed in other limitation, inline code suggestions, they are not that bright, so that's smart. We don't have an Eclipse plugin that is really working. There are some limitations there. There is an open source plugin that can be used over Developer Studio. But that one was, we dropped it because there are some dependencies that then are in conflict with the Progress plugins. Not ability to integrate other repositories, is vulnerable to attacks, and contextual understanding is not always the best. Okay. This was our conclusion. So if you want to use Copilot, we can use it, but we should see it as a pair programmer. So we cannot rely on actually generating the good code from day one. We should prepare it first, and for preparing we need to do some sort of, at least in this strategy that we use for prompting, we should use at least a prompt dev that should train based on the existing structure and the framework. Okay. The compatibility, so as I was saying, it's working with Visual Studio Code really well. With Copilot for Eclipse plugin is not working, causing a lot of errors. This is due to the conflict with the dependency. It's important to know this is what we discovered. If we have 2 sessions of Visual Studio Code, he tries to take an answer from one project to another. So we try to, doesn't know that, hey, I have 2 sessions, 2 projects. He's trying to give me suggestions based on the other project. Then we start asking a lot of questions. So until now, we managed to generate something. We have an OERA structures, but can see files that are not open. So in this way, we start to investigate, hey, I'm locally. The answer was, for OpenEdge is Yain. If we, as a developer, open strategically what we want to be included in the context, then he can see it. If everything is closed, he doesn't see it. Only if it's in previously prompts that we already tried. Okay. Another one, another important settings. Allow my code snippets from editor to be sent transparent to the global model. These settings was available for, I think, for individual. For business and enterprise wasn't there. This one is sending snippets to the global model, and with those snippets is retraining the global one. This is how we create the context. So in this case, we strategically open what we want. So these are the files that we want to be included. There is also important for the context, also two things: the comments on the top of the file. So this one, I don't know who used to write the purpose. Okay, that becomes really important. So you should start writing a purpose. Here we see data access class for table country on the top of the file, and also what's important to start commenting also our methods, to have a header above our method to put, hey, what this method does. Because this will be included in the context. As we see here, what do we see here? Okay, based on previous prompts, it gives us the results. So we already refined for the service interface, and he's tried to generate it. And what's included here, we already opened, as we saw in the previous slide. We already opened the files. So we have SE open, we have what we want, we put the comments in the purpose. We put it in the purpose, it doesn't matter. It should be in the comment in the top of the file or above the method. And now we have them included, and is generating further. Okay. I talked a little bit about context. This is really important. So the context is built up based on multiple things. These are the three most important things that we noticed. So usually when we're writing code, we have a source, right? So we have a .p, a class, and in that class we have our cursor usually, and we select one character from line 200. Well, I hope not 250. And what's above the cursor and below, it's really important when we put in the prompts, because that one gives us a 10% boost in acceptance of response that chat returns to us. File name and type, this should be open. File name should be properly described, what's in that file, or what's the entity that is doing, and the type of it. So because we install the Riverside language, ABL language server, the type is really important. So we need the classes, the W's, includes, and what we notice, the openings. If you strategically open the right files, the acceptance acceptance of the response increased by 5%. How it's working, how it's handling data. Developer enters a code, so he enters a prompt, says, hey, give me this, give me that, takes the before and after, the file name, what's after it, what I already have open, send them to a proxy. The proxy eliminate filters, some part of it, so eliminate toxic language, hacking attempts, and then it's sent to the global model to send, hey, give me the suggestion for my code and for my prompt, for my request, and give me back when the return is done. Step 4, there are n possible types, so like can be multiple responses. Those are filtered out based on the local context that we already sent, and then they are encrypted again and send it back to the IDE. Yep. The way it works behind it is based on AI model developed by GitHub, OpenAI, yeah, Microsoft, GitHub. It is trained on main languages. So this is what was one of our reasons to try to see if it's working and how it's possible to work with it on ABL. It's not yet at the level of main languages, TypeScript, C#, C++, but it's usable, and it really gives us a speed in development. Why use it? When we have repetitive tasks, something that we already trained based on an architecture, developer says that it's 55% faster on main languages. What we noticed is at least 40 if you train it for ABL with a specific framework. It's working really fast when you have repetitive tasks. As you see here, 96%, the perception of the developer. Yeah. And the speed we noticed also during our test. What slowed us down was the number of prompts that we need to give in to the model. Yeah, we figured out a possible strategy, so that one, before we start to develop, we just need to make sure we train the model with our framework. So make sure we are able to generate the sources, what we want, in what format we want, what methods we want, and how we want it before the entire team start to develop and work on the application. We initially started with inline, with a part from the left that's based on GPT 3.4. That has code completion, suggestions, can give us small pieces of code. It didn't took us a day to notice the hallucination level is like sky high, and GPT 3.5, yeah, not the best, but we learned something from it, is that the model, every model tries to give us, to please us, no matter what's the result. So we drop it because the response weren't acceptable by us. So we drop it and move it to the chat, where was currently introduced GPT-4 with the interaction. We have a lot of explanation, a workspace context, large pieces of code, and there we started to notice that, hey, it's quite usable. So like the results are really usable if we refine them. And then we continue to based on that one. So this is why we choose the prompting for training the local context. Some of the other features, we can instruct the Copilot to explain, to generate tests, to fix some problems. Yeah, we have some scaffolding, we're searching, we can generate API or some sort of documentation. Yeah, this is an example of explaining. So we're trying to explain some piece of a code. We see that it's quite detailed on the left-hand side. So to provide the code, as mentioned, in the right-hand side, we just select it. So this is what you want to explain. Put a prompt, generate me what's going on here. So I don't know what's in this piece of code. and he provides a detailed, quite detailed explanation. Similar. Yeah, here we have a context. The test class is generated correctly because it has a model from another test class, but we already dived in that one. Okay, this is how we trigger inline commands. So this is what we did. On the left hand side, we opened a source and we triggered. Should be common right now, double stars. We selected the code and says, oh, optimize this part of code. What we see on the right hand side is what Copilot already did for us. So the next step for the developer would be, hey, does it make sense to be there? So it should be, is it rational? So makes sense to have it in my flow in this kind of form. Okay. This is how we can generate from comments. This is the part from the inline extension. So we just put a comment there, purpose, update a file attachment. We have a parameter, ds file, as a data set that contains file attachment which will be uploaded. And Copilot immediately knows what the code should suggest and how it should look like. And it's up to the developer to accept or not the results that is generated. This is another feature, code completion. This we notice that it's working by default. Yeah, here what we did, we start a loop for each TT file attachment. We just put create an attachment, above file attachment, and he immediately suggests us, hey, use buffer copy TT file attachment accepts some fields to buff file attachment. Okay. What is Copilot? So we started in reverse order. As you noticed, is a tool that helps us to generate code. Has main feature is comments to code auto completion, and the chat that we used in this session to generate to refine and generate the responses that Copilot returns to us. Okay, and this is a slide about Wayfair. So I think we reached the end. So we are Wayfair. We have 12 plus years of experience. Yeah, we have a lot of expertise from Progress, mobile, DevOps, web UI, and everything. So we have a booth here. So if you want to know us, my colleagues are at the booth. Thank you, everyone. If there are any questions, yeah.
How did you determine the context? You had so many examples like the files being opened. I don't even understand if the files need to be visible side by side or just open as a tab.
Okay.
Position. How do you determine that is the context?
Can you summarize the question so the badly got here?
Yeah. This is a good question. So the question is how we determine the context. The context. Well, we put another question above it. How the context look like, and what we managed to figure it out. There is an option to export the history of all the prompts, and in the history of the prompts we have the context. So there you have is saying in plain text in a JSON. It's saying, hey, you already have opened this file that's called bcustomer.cls. Your cursor is at line 10, column X. Before it, you have this part of code, but it's not the code itself. Is the number of from line to line 5 to 10. So and then below. So these are included. Other questions?
So the link to GitHub, that is only used for training. You don't need to have a repository in GitHub or anything like that, since this is running on a local.
Yeah. The question. Okay. The question was for the back. You don't need to have your repository in GitHub. We use our works. Well, our projects were individually on our local machines, and the only connection to GitHub is the account for the Copilot, so he can know the global model. Hey, give me the response from there. Other questions?
Can you bypass the 6,000 characters limitations?
Yeah, this is a follow-up. We still investigating this one. We know it's possible in one way, but we need to bulletproof it.
For example, if you were to start up a Copilot or an OpenAI project in Asia, which is not the same thing, but still similar engine, the way to bypass this is to switch to Sweden.
Sweden.
Yes. Not use Western Europe because it's overpopulated. So Microsoft tries to divert everyone into Sweden.
Okay. So the solution here, thank you, Mircea, bypassing the 6,000 characters is just to move to Sweden. So.
Not literally, but with your data centers. Yes?
Other questions? I don't know Sweden, so.
Das sagt man all in Sweden, huh?
Thank you, everyone.